Once upon a time, a couple years ago, our internal engineering team had a problem. They wanted a way for people to be able to deploy a feature branch to one of many QA environments without having to keep telling people, what commands to type and what Kubernetes manifest to edit. And if the infrastructure changes, the commands changes. So they wanted a web interface where you can go, find the QA environment you want to deploy to, pick the service, and deploy your feature branch. And so after much discussion, it was decided that the most productive tool to use to get this done would be LiveView, obviously. And it was great. As most internal apps goes, it was 1 or 2 people working on it. And within record time, they were done with the thing. You could see, you'd be looking at the screen, and in real time, if somebody else claimed a QA environment, it would change on your screen immediately. If you're searching for something, the list would filter down as you're typing. And all of this with minimal programmer effort, which was just great. LiveView was the hero of the day. But a couple years later, SalesLoft kept growing. The amount of QA environments grew a bunch. The amount of services you could deploy grew a lot. So the amount of data that this app was managing and letting you interact with grew exponentially, and it became slow. And the first time I looked at it and I asked, and I said, well, can this be made faster? And it seemed a little bit hard to figure out exactly why. I mean, OK, can I skip to the next slide here? I don't see a mouse. OK. Yeah, so the first time I tried to make it faster, I dug a little bit, and I saw, OK, there's nothing obvious making this slow. I don't know why it's slow. I've got other interesting Elixir things to work on. I'll work on other things. And then somebody mentioned, well, if this is how LiveView performs, then I'm not impressed, and maybe we shouldn't be using it. And that made me go, whoa, whoa, whoa. We can't let history be written that way. Like, I knew we're doing something wrong. I knew LiveView would be great at this if we just fix whatever we're doing wrong. Now I just got to go find it. And I started digging some more, and I realized, OK, this is kind of hard. And part of my problem was how I was looking at it. The way I was looking at it was that, oh, it's just an Elixir app. It's got Elixir processes talking to each other. And there's going to be some bottleneck somewhere. And I started looking at, OK, does it have enough CPU and memory? Is there a blocking call, blocking process waiting on an API call? I was thinking, OK, we're using GitHub to get a bunch of PRs. Maybe we're getting rate limited. And I started feeling, not finding the problem right away, started feeling a little bit overwhelmed of, OK, where would I start even digging? And I spoke to my mentor about it, and he said, oh, no, I know exactly what's wrong. We're just rendering too many elements on the page. And I said, OK, all good and well, but how would I have known that? And what can I point to show that, hey, look, right here, this shows that we're just rendering too many elements on the page. We just need to stop doing that, and then everything will be fine. So yeah, that made me look at it in a different way, that it is actually a JavaScript application, a LiveView app. So yeah, you didn't write any JavaScript when you created it. The LiveView team wrote all the JavaScript. It all exists in the framework. But you don't need to write JavaScript when you create the LiveView app. But it is a running JavaScript application. There's JavaScript running to change DOM elements on the page. And so we've got to think more along the lines of Chrome DevTools, checking render time, looking at the messages coming from the back end to the front end. How is the front end handling those, and so forth. So it wouldn't be a LiveView talk. Well, for all my LiveView talks, I feel like I have to have a live demo. So you could go to speedy.fly.dev. And if any of you are front-end designers and beautiful design is really important to you, I won't be offended if you walk out now. But so what I've got here is a little example LiveView application that just renders a list of people. and it updates some of them every second. So every second, there will be some updates. And I don't know why, but in our UI here, we're going to go bottom to top just because. So in the bottom here, you can put in higher numbers or lower numbers for how many people you're going to render. So this I figured, OK, this will give me a good example of figuring out, OK, at what point do I have too many elements that I'm trying to deal with? Is it 1,000? Is it 10,000? So one of the first things to do that I would suggest you do if you feel LiveView getting slow is log things from the back end and look at your logs while looking at the LiveView and try to see if the front end is falling behind the back end. Now, I don't have a way for all of you to read the logs for this example app, so I made this tick at the top left global. So if you open 2 tabs, you should be able to see, OK, let's see, can I, whoop, no. Can I computer while people are watching? Let's see, I'm going to go here. Command tilde, the tilde is in a different place with this keyboard. Come on. Yeah, here's speedy, OK. Control L, no. OK, speedy.flat.dev, I'll just type it in. Enter. OK, waiting suspensefully. OK, whatever. If it works on your machine, and you open 2 tabs, you should see this tick at the same place on both tabs. Let me see if I can still get this going. This would be really helpful. Speedy.flat.dev. Enter. Yes. OK. So on the right, oh, no way it's happening. I think y'all are crushing it with too many users at the same time. OK. Well, on the left, it's working. So you would see when this tick starts to fall behind where it's supposed to be. If you've got one tab with only 1 user and another tab with 1,000 users, this tick should start falling behind. And another way to see it, if that doesn't work, it's funny how one tab's working fine for me, but I can't load up 2. Another way to see it would be Chrome DevTools. Where would I get inspect? I'm on the conference laptop and the keyboard's different. How would I get Chrome DevTools? I can't get a right click.
Safari, not Chrome.
I'm in Safari? That would cause all the problems. Yes!
Yeah.
Yes, we found the problem. OK. I clicked the link, and it opened in Safari. Yes! This is going to explain everything.
Safari again.
Yeah, I clicked Safari to try and make sure I'm not using it. Force quit it. OK. All righty.
It takes 2 developers to debug it.
Yes! I'm obviously on the conference laptop. I clicked that link. It took me straight to Safari. Confused me all the way. OK. So anyways, you would get the, alrighty. You get the developer tools. Come on. Get the developer tools in the network tab. You get the, here we go. In the network tab, you look at the WebSocket. Click on messages. Now, how big is that on the screen for you? Way too small? In the back, can you see any of the text? Should I zoom in? Is that a yes? No? Yes? So you want to look at the WebSocket, and you want to look at messages. WebSocket closed before the connection established. OK, WebSocket. There we go. So we see these WebSocket messages coming in. And if you see more WebSocket messages coming in than what's updating on the page, so you would see a lag. If you're rendering too many elements on the screen, you could see WebSocket messages coming in, but the page is not updating. So what's happening is the back end is sending a WebSocket message to the front end with data that the front end needs to update, but the JavaScript on the front end is running and doesn't have enough time to actually do the updates on the front end. So that's one thing you can see and look at. Something else, now that we're looking at these WebSocket messages, you can look at the contents of them and see what's in there. So, OK. I'm assuming you can all see that because you didn't complain about it. But if we look here, we'll see these lists. The messages coming from the back end right now includes the entire list of 15 people. So on every message from the back end is sending an entire list. Only a few of them are updating. Every second, we're updating maybe one or two. But to be exact, every 12th one is what we're updating. But we're sending the entire list from the back end. So that is something that you could fix with LiveView components. So over here at the very top, I tried different ways of rendering the list to see if it would perform better. So if we switch over to live components, then we should see messages come in. OK, can I drag this a little bit? Yeah, new messages are coming in after switching to live components. Now, if I look at these messages, I'm seeing only the element that changed. So that would be the difference in using just rendering a list or rendering with live components. And if you're thinking, well, what's the difference, or how would the code actually look different? I made this right here, I made a link to the code. So if you click here, it would take you to the little bit of code on GitHub that renders each person. And so, or renders the list of people. And so you could compare how the different ones would interact. The other thing you would notice is that now that we're only sending the elements that changed, our message length is much smaller. If we go back to doing normal Heeks inside comprehension, right now our messages are well, let's render more elements here to really show the difference. Let's do 1,000. So yeah, we've got 1,000 people on the page now. Wow, after actually finding Chrome, things work a lot better. Now my message length is 35,000. And if I switch to live components with number IDs, you'll see the message length is about 1/3. So if your problem is network speed, if you've got users on mobile connections far away or slow network speed, or for some reason your payloads are large, this could get your performance improvement. Something I noticed is that when I use live components for very large lists, the live components actually performed worse. I think maybe the JavaScript is doing more work there. If you're a JavaScript expert, or if you work on Morph DOM, feel free to try and use this to get to the bottom of it. The most obvious fix is to show less elements on the page, which is what should have been the fix all along. So if you choose paginate here, then let's see, oh my word, I know all the keyboard shortcuts when I'm on Chrome. I just feel so at home right now. I was really nervous in the beginning where I'm like, nothing works. What has happened? So now we have only 15 elements per page and a whole bunch of pages, and getting between them is fast, and this thing never falls behind. Let's try, you know what, I'm feeling ambitious. Let's try this thing again. let's see. Speeding.fly.dev. Yeah, here we go. So I've got 2 pages, and the tick on the right should match the tick on the left, except when the left starts to fall behind. So, OK, this screen is smaller. Why don't we do this on the left? So just the tick sticks out. And we do this on the right. There we go. All right. So now, if I try to render too many elements, this is going to start falling behind. And let's try and see where that is. Is it 10,000? So already we see a little bit of a hiccup. On the right, we're stuck at 236 for a while. And on the left, we're already on 244. The left has started to run again. But this for me, and for you, it might just logging on the back end would be easier. This for me was the easiest way to see that, OK, the back end is actually fine. The back end is sending messages. The back end is staying up to date. It is JavaScript running in the front end that's not keeping up with us trying to render too many elements. And yeah, obviously, if you paginate, then you're going to be just fine. Something else that feels kind of odd is if the front end gets behind, if that JavaScript process gets behind on all the updates, whatever you do just feels slow because it's going to first do all the other things it had to do before it makes the change you wanted. Something that, I don't know if this makes much difference, but I just felt like doing it that way, just in case anybody is like, well, LiveView couldn't really render that many things, or Elixir wouldn't scale to that. So we've got 10,000 pages here, or 15 per page. So we've got 150,000 elements. And you might think, oh, yeah, you could just render a random 15 elements for each page and each person viewing. If you look at your neighbor's computer, you'll actually see the exact same elements on the same page. So there really are 150 of them, and we're really updating the whole list every second. And it turns out fine. Obviously, don't do this unless you have to. LiveView would make it very easy for you to see which pages actually have users. And so we could update only those pages, but didn't need to do that here. And then, yeah. Oh, I don't think I ever finished showing the message. No, I did show the message size, that the size of the messages gets much smaller with different ways of rendering here. Another thing to look at, and again, I can't give you an exact step-by-step where to start and where to end, so I'll just give you a grab bag of different things you could start with if you find yourself with the LiveView application that's feeling slow. Another thing you could look at is, so inside Chrome DevTools, there's a little 3-dot ellipses menu. Not that one. It's the normal 3 dots. Here, I want this to go away. The normal 3-dot menu up here. If we click this, and there are more tools, and then there are Task Manager. So Task Manager here, we can see, OK, which tab is using how much CPU and how much memory. So rendering 10,000 elements, we're only using 50% of the CPU. So I guess we could try and do more. Oh, see how it just crashed? That is something you will also see. So if the front end gets behind the back end for too many seconds behind, it'll just reconnect. And if you find that is happening to you, and you're thinking to yourself, wait a minute, I was just about to figure out what's wrong, or I was just about to get more information, and this thing just reconnected itself, and the mount function on LiveView runs again, and we start with the default assigns, then something you could do is you could change the heartbeat interval. I'll have a little code snippet on a later slide to show you how to do that. But this heartbeat, let's see, if we look at the network tab, when we reload, and we look at the WebSocket, by default, every 30 seconds, the front-end JavaScript sends a heartbeat message to the backend. And if, so the down arrows are messages coming from the backend. It'll be up arrows like this one. And they're only 30 seconds. I'm not going to wait for one. But you can change that heartbeat interval to be longer. I don't have a reason to keep it that way. I haven't thought of a reason, but except for debugging, where if the front end falls behind the back end, it's during that heartbeat that the LiveView will figure it out, or the front end JavaScript client will figure out, OK, I've tried to send the heartbeat. I'm clearly way behind the back end. Let me just reconnect. So you could change that interval, that if you made it really long, then it won't try and reconnect. Or if you made it really short, it would reconnect very soon after it falls behind. It will do a reconnect. If you want to see that reconnect, you all got me nervous now with things not working in the beginning, so now I don't want you to all do it at the same time. But if you put in a number that's clearly too big, then you'll see that it reconnect pretty quickly, because or within 30 seconds, because the front end will clearly fall behind the back end and have to reconnect itself. So anyways, I'm going to force it to reload. I want to show the next thing. Oh, it's not uncommon for Chrome to become totally unresponsive when you try to do this many things. I wonder if I just do a new tab. Come on now. Something else while I'm waiting for Chrome to become responsive again is that the try it on different machines. That things just behave differently on different machines for me. OK, we're back to responsiveness here. Something that I found is when I make a list that's too long, as in you should not make a list that long, that I think I mentioned live components, even though the WebSocket messages are smaller, actually performed worse for me. Well, this is not my laptop, clearly. My laptop is a like a 15-inch MacBook Pro from 3 years ago. I had a coworker with one that was just a year or two newer. And for him, live components performed better, while they perform worse for me. So maybe the JavaScript is using some hardware extension that's on newer machines, that's not on older machines. So definitely try it on different machines if you're running into a performance issue, for sure. And yeah, what we're about to try often makes Chrome misbehave. So we'll see. Let's see how this goes. OK, let's go with the unreasonably kind of large number. Or OK, let's go small first. What if we just had 100 elements? So in the performance tab, OK, clicking it again. Come on now. OK, one element, surely. Surely the performance tab works for that. Yeah, sometimes when you render way too many elements, I have crashed DevTools. And then, yep, this X out here is totally unresponsive. So let's try in a new tab. What's that? OK, let's try this again. OK, performance tab. And yeah, if you couldn't tell by my front-end design skills, my job title says full stack software engineer. But yeah, I just do that for the money. Like I'm much more comfortable on the back end. So a lot of these things that I'm showing you are things I learned recently. So I thought if you're at an Elixir conference, then maybe these are useful to you too. So if we record here, just let it run for a few seconds. It'll process. OK. We'll see once every second, we see this really deep stack trace. And no need to, or really deep call stack, no need to try and read all the words. We're not going to get into which actual JavaScript functions are being called. But the idea here is we can see we are calling once every second. there's a bunch of JavaScript executing, which, I mean, it's a lot easier to figure out what's happening in this example app because the example app updates things on the page once every second. But if it's a search as you type or something like that, you would want to hit record and do your search or do whatever thing happens slowly for you, and then stop the recording and come look at, OK, what is happening here? And if we now, I don't know, is everything just going to crash again? Let's try with 1,500 things on the page. We'll record for a couple seconds. OK, everything good so far. It seems happy. OK, you'll start to see these call stacks are getting a lot wider, and the time is horizontal. So every second now, we're doing close to 1/10 of a second worth of work. So we're really not in trouble yet. So let's see what happens if we go to 15,000. All right. Yep, I see the tick incrementing on the left. And we're recording it, so I think we're going to get the data we want. Let's see what it gives us. All right, so here is the problem very well defined, that when your LiveView application is running slowly, or in this case, if you've got too many elements on the page, every second we're telling the front end to update something, but we're telling it to update so many things it needs 2 seconds to make the update. So those call stacks are getting wider and wider and wider. And yeah, at some point, the whole thing is just going to start falling behind. In fact, it's already fallen behind, and it's reconnecting. So yeah. Anyways, hopefully, some of those tips and tricks are things you could use if you find your LiveView getting slow. Let's get back to our slides. All right, the live demo. I was very worried there in the beginning, but I'm happy with how it ended. So yeah, some things we did go over were logging from the backend process, seeing if the front end is falling behind, using that performance tab. The Chrome Task Manager, it's the 3 dots in Chrome, not the 3 dots in DevTools. The network tab and looking at those WebSocket messages. Try live components, try it on multiple clients. Debounce is something I did not talk about. So PHX debounce is a built-in debounce in Phoenix Forms. And it's especially useful if you have multiple users interacting with each other. If these users are doing something and these users are doing something, and one user doing something in a form is going to change something on the screen for another user, debounce is something you want to consider. That if, as they're typing, if you're sending a message between the backend processes for each keystroke, then yeah, you're going to have more messages, and that could cause an issue on the front end because the front end is getting too many update messages from the back end. Or it could cause an issue on the back end with just too many messages being sent back and forth. One place where I use debounce, so SalesLoft paid for my travel out here, but they also said, hey, could you please give your talk as a lunch and learn at work? And at work, I knew there were going to be people showing up to this lunch and learn who, it's a larger or mid-sized company. There were going to be people showing up that have never used LiveView. And if I go so deep into LiveView with them, they would just be like, well, why am I interested in fixing performance issues in this technology that I've never worked in? So I figured, OK, what can I show them that could get them at least a little bit excited that, OK, this is why you'd want to use this thing. So the morning before that happened, the morning before that happened, this is bothering me now. I want to close DevTools, and the X is off the screen. There we go. The morning before that happened, I couldn't sleep. I was awake before 6 o'clock and trying to go back to sleep, and I couldn't. So I figured, OK, fine. Let me get up. I've got this idea. Between 6 a.m. and 8 a.m., I added this page overview. Go to /overview. So this is all of you viewing this right now. So one of you have only one element on the page. Looks like all of you have Heeks and side comprehension. So if one of you would, OK, somebody just put in 39, and then they put in probably higher than 30,000, but I made 30,000 the max. And so, yeah, so in real time, as users are changing things, this page would give a real-time overview of that, which, and again, those 2 hours, that wasn't just me writing code and making things work for 2 hours. If I could do that, it would be a screencast on YouTube right now. There was probably about 15 minutes of making progress. Most of the time is just me, remember, oh, how do I do this again? OK, find the documentation. I thought I was supposed to get an error here for the handle info message that wasn't handled. Why am I not? LiveView just makes it ridiculously easy to give you a view of what another user is doing in real time. But for those things is where you want to debounce. So I'm definitely doing a debounce here. So you might not notice it with a few elements on the page. If you've got just a few, it's instant. But I'm not going to try and show it to you now. But if you've got more than 30, there's a little debounce that if you rage click it a bunch of times, the page doesn't actually update until you're done. Or if you're busy typing a large number, the page doesn't actually update until you're done typing. So definitely consider debounce for a situation where each thing one user does can cause all the other users to have to re-render some of their DOM. Here's the little heartbeat interval. It's in your app.js. That second line from the bottom is not there. But find where the live socket is being created, and you could change the heartbeat interval. The default is 30,000, so you could make it longer or shorter if you want your live view to be able to fall behind the front end and keep trying to render while not reconnecting. One more thing to consider is just how many messages you're sending between live views. So in our case, the example I just showed you, this is how the messages go. If one of you change your number or one of you change something in the form, there is an event being published that everybody's live view is listening to, well, everybody looking at that overview page, every one of those live views are listening to those messages. So each sender is sending a message to all receivers. And so, this just doesn't scale. At some point, there are just too many messages going around. So so my little icons here, each one is a live view process, a little Elixir with a Phoenix inside. So something you could do is that each live view process, and notice the arrows are different. Here, there are bidirectional connections between them. I think we've got 10-odd bidirectional connections on the page. But if we were to add one more, we would need to add 5 more bidirectional connections. In this situation, if we add one more, we only need to add one more bidirectional connection. So in the middle, you could create a gen server that listens to the topic where your live views publish their changes. So if a user makes a change or a user changes some state, they would publish to some topic. And a gen server listens to all of those. So if there are many, many, many of them coming from different users, that gen server will have to process all those messages. But you can process them once and aggregate them and then send them out on a different topic and let all the live views listen on that other topic. So the reason I've got 2 arrows here is because the arrow that the live view is processing on and the other event that the live view is receiving on can be different messages where they get, maybe everybody is typing at the same time, sending a huge amount of messages, but you can aggregate them and rate limit them on how fast you're telling all the live views to re-render their screens. Definitely something to consider. Now what? So if you find yourself in a situation where you've got a live view app that is starting to slow down for some reason, it can be solved. You can figure out what's going wrong. Even though, like in my case, I would have been much more comfortable if it was some Elixir thing. I was not as comfortable working with front-end things. It can be solved. Hopefully, I've given you some trailheads to start, some places you can start scratching to try and figure out why is this thing slow. And hopefully that's helpful to you. Something also I just want to throw out there. I've heard of many companies, many startups starting with LiveView and doing LiveView in customer-facing scenarios and not just internal. At SalesLoft for now, SalesLoft is definitely older than LiveView. And so for us, LiveView is mainly internal, for internal tools. But if you have a story, or if you have tried this and succeeded, to turn on a new LiveView application with hundreds of thousands of users on day one, where you didn't start at zero, you didn't start with a small startup, but you turn it on for an application that was already at load, then you need to come tell that story. We need to hear that talk, because that's still a new one. That's still one I don't have an answer for. So, and I'm sure we're going to look back at this and think this is funny, because I think in the future, it'll be a very common thing for large startups to use these. So yeah, that's what I want you to go do with it. But any questions? Yes?
Did you explore lazy rendering in what's visible in the viewport instead of rendering everything that's already off screen?
Right. So yes, sure. Did you explore lazy rendering and only rendering what's visible on the screen and not rendering all the things that are off the screen? At work we've got a library I think called React Window where we do that. I didn't actually Google if anybody's done that with LiveView. I'd love to hear about it if anybody did, but that would be ideal. Yes, over there.
Just saying there, thanks.
Thank you. You had a few other options there. I think there were 4. How did they compare, for example, the list comprehension with IDs?
Yeah, it was more trying to see. It was just a question that was asked. Well, so with a normal list comprehension, what if we just add IDs? What if we just give each element an ID? Does it get better? And not really that I noticed. I didn't really notice it get much better. I more kind of left that in there in case somebody sees this talk and they work on MorphDOM and they want to make it better, then maybe there are more tools for them to look at. But yeah, no, I didn't really see anything. The only main difference is, do I use live components or not? That's the main difference, where I see a huge reduction in the message size. And on my machine, the live components aren't any better. Now, don't go repeat that Devet said live components are slow, because I'm showing it to you in a scenario where I'm doing something I should not do. You should never render that many elements on the page. Only in that scenario did live components behave slower for me.
There was a question. There was a couple of questions actually in the Hoover app. If you're not using the Hoover app, if you want to ask questions, you can post them in the Hoover app, by the way. And I think I know the answer to this. So, did you try building a similar app with a JS client-side framework to compare?
I did not.
No, I thought.
And I mean, React would do this very well, because I could use something like React Window and only re-render the things on the page. I think the competitive advantage here is how little time I spent. Yeah. Like I wouldn't just go ahead and build example apps that do nothing just for a talk if it's going to take me that much time to do. Well, where the killer feature of LiveView is how little time it takes to make something.
There was one other. Well, there was a comment about Safari being underrated, and there was also a mention that you can use window.livesocket.enable debug inside your console. So that might be something to explore.
Yes. Okay.
And that's it. So thank you very much. That was a fantastic talk.
Thanks so much.